we're going to talk about a concept here called torque. Now, torque is something called it's a turning force. So what is torque defined as? It is defined as the force. It is the product of the force and the distance from a point of rotation. So I noticed some people are familiar with it. I got Victor and Shazad. This is excellent. Now, for those of you that are not familiar with torque, it's okay. It's okay because I am not going to test you on torque. I am not testing you on torque this semester. This question here is straight from the textbook, and it's kind of like one of those extend thinking type questions. I do spend an entire booklet. Keep that in mind. I'm going to spend an entire booklet, an entire lesson on this topic next semester. And for those that are curious, I've actually kept the lesson on YouTube. That lesson is on YouTube. If you want to see ahead to the next course, that lesson, I'm just going to leave it there. It's okay. It's still there. I'm just going to leave it there. And that's when the COVID stuff happened, and then we went online. At least we went online. I don't remember when you guys would have gone online in high school if you were in high school last spring, but we went online exactly when I was teaching the torque chapter. So from that point on, I was posting everything on YouTube. So anyway, the formula for torque is the product of the force times the distance. So let's take a look at this question and kind of make sense of it. So you see here, see this little triangle thingy here? This is a balancing point. So think of like a teeter-totter. Think of two kids on a teeter-totter or a seesaw. So it looks like there's actually three forces acting here. There's a force acting here, F1, and it's acting down. That means that this thing here would rotate. It would rotate counterclockwise. It would go like that. See, it would topple over that way. And then this force here and that force there, we're going to make it want to go this way. So some of them want to go clockwise or some of them want to go counterclockwise. But the idea is that in order for them to be in equilibrium, because we want them to balance each other, the whatever goes clockwise has to balance out whatever goes counterclockwise. So let's talk about the first configuration then. The first configuration says that the clockwise to counterclockwise torques. Let me delete that. Okay, so in this case, there are three forces. And I'm looking at the first configuration. So there's F1, there's 20, and there's F2. So F1 is going to turn it clockwise, or counterclockwise. And then F2 and 20 are going to turn it clockwise. So that's the formula. Now, torque is the product of the force times the perpendicular distance from the specified balance point. So in other words, how far is F1 from this pivot? How far is F1 from this pivot? 3 meters. That's the torque for F1. How far is the 20? How far is this 20 force, 20 Newton force? How far is it from the pivot? Thank you. And how far is F2 from this pivot point? Thank you, Ahad. 3 for 3. And Dogan, 3 for 3. Look at that. So that's the formula. So let's organize this. Let's make it look a little bit prettier. So I'll say 3F1 minus 5F2 equals 20. Congratulations. That is your first equation. Notice that this question Okay, I'm just going to tell you this. When you see the solution to question 17, the solution to question 17 is a marathon, people. It is a marathon of a solution. Some students couldn't fit it on the page. That's how long it was. But this question is not a marathon. This one is more of a finer detail of physics, a finesse kind of a question. That's why, because it's so it's founded on physics so much, it's difficult for me to ask you to answer such a question in this particular course, because this first half of the course is learning the math and reviewing the math that you should have learned already. I mean, maybe you know it, you're just reviewing it. So, but this kind of question, we're going to do a whole bunch of them, but we're going to do them in March, not in October. So let's try the other configuration. So let's take that second configuration. I'm just going to copy and paste this again. So these distances potentially are different now because now the forces have moved around. So in the second configuration, the same force here, maybe this is a teeter-totter. It's kind of lopsided. Maybe F1 represents some kid that sits over here, and now this kid shifted along and moved over here. He moved closer to the pivot. So how far is this force here that is going to turn the this structure counterclockwise? How far is it from the pivot now in the second configuration? Yeah, it's 2. Did the 20 move at all relative to the pivot? No. So I can just copy that number there. It's still 1. I shouldn't have deleted it. There you go. And how far is F2 from the pivot now? 3. 3 for 3, Ahad. Again, you just pulled Michael Jordan. You did a double three-peat. Nice. Ahad, I'm going to call you Michael Jordan from now on. You're MJ. You've been rebranded, my friend. Respectfully, of course. Okay. I really, as a group, I love your positivity, people. I like the fact that you guys help each other and you are very, very nice to each other. It's a very good thing. So I really appreciate that. It means a lot. And you know, it's one of the things I love teaching the degree students, especially, is that level of camaraderie, that teamwork that you guys have. It's unparalleled. I've taught at U of T. I've taught like at George Brown and other disciplines and what have you. And the degree program is really like one of the reasons I love this place and teaching here is the fact that the degree students, especially all the students, but specifically because I have so much experience with the degree students, so much fun. You guys are an absolute joy to teach. So anyway, doesn't this look like flashbacks now? Isn't that a flashback to something? I'm going to do it. I'm going to do it. I'm going to pull out a table. I'll use a table. Let's do elimination. We've done enough Kramer's rule already. If you want to use Kramer's rule, let's go back to elimination now. Yeah, we're done with Kramer's rule for today. Just excuse me organizing this for a second. I wanted to make it look nice and pretty for you. Thank you, Ravina. Okay. Seems to have 2 lines. Not sure why. Okay, so I'm going to copy that equation here. I don't know what happened there. Okay, what would you like to eliminate? Pick one, F1 or F2. What do you want? F1 it is. Okay, so we're going to take the 3, 2 and write it backwards as 2, 3. You could also use substitution here if you like. That's no problem. So let's take this equation here and let's double everybody. So 6 10 40. And let's double the second equation. And sorry, triple. So 6 9 60. Can someone confirm that these are correct to them? Do those look correct to you? Thank you, Brian and Kiara. Here we go. So notice that F1 has the same sign. So we're going to subtract. So the same sign, I should say, for okay, so if we subtract them, let's do that here. We have negative 10 minus 9. So that becomes negative 1. So negative F2 equals negative 20. And yes, F2 is 20. Thank you, Syed. Okay, so that's 20. Now that you have that, you can go back and get F1 whichever way you feel like. It doesn't matter at this point. So I'll use find. Determinant sounds like determinant. So let's write the first equation here, just because I feel like using whatever equation comes out first. So we'll put in F2 here. We know F2 is 20. So what's F1? Just give me the answer for this one, please. No steps needed. Yeah, thank you, Ravina, for the win. Ravina for the win. There you go. Okay, that's enough. That's enough, people. I quit.